Now, the top view of a line capital PQ is 75 mm long, measures 50 mm. The NP is 30 mm in front of VP and 15 mm above HP. The NQ is 15 mm in front of VP and above HP. Draw the projections of the line and find its inclination with HP and VP. Find the length of the front view and distance between the end projectors. So we need to find out the inclination with respect to HP and VP, that is theta and phi, and also the length of the front view, which is P dash Q dash, and also the distance between the end projectors, and also the alpha and beta, that is apparent inclination with respect to HP and VP. Now, the NP is 30 mm in front of VP and 15 mm above HP. So when you look from the front view, you can see the distance above HP. That image will going to be seen in the vertical plane. So that you will going to mark this point as small p dash, and this will be above HP by 15 mm. Now when you look from the top view, we can see the distance in front of VP, which is 30 mm in front of VP. So that distance is seen in the horizontal plane when you look from the top view. So that point will going to become small p. Then NQ is 15 mm in front of VP. So when you look from the top view, the NQ is 15 mm in front of VP. So you can measure the distance of 15 mm from the XY line and draw a dashed dot line in the top view, so that you will going to get the locus of Q in the top view. But it is distance above HP, but he has not given any distance above HP, that we need to find out. So the top view of PQ of a line PQ is 75 mm long, measures 50 mm. So he has given the true length and also the top view is given. Since we have the locus of Q in the top view, so naturally you can find out the true length and as well as the top view point of Q. So by using the compass, with measuring the distance of 50 mm with P as center, cut an arc on the locus of Q, so that you will go to get the small q here. Then you draw a dark line between P and Q, which is the top view. And also 75 mm long, he says, so with Q as center, take the radius of 75 and cut an arc on the locus of Q, so that you will go to get this point Q2. Then join these two with little bit thicker than the projector line, which will be PQ2, which will be the true length. And this will going to be the inclination with respect to VP in the true length, which will going to be phi. And this will going to be the apparent inclination with respect to the top view, which will going to be beta. Now, since we have the top view, so we can get the front view of this point should lie on this end projector. So draw a vertical projector from Q to the XY line, and from here draw a vertical projector in the front view. So that will going to be, the image will be on the vertical plane. So now we know that the front view point of this should lie on this line, that is Q dash should lie on this line. But we know the top view true length. If the top view to be true length, then its corresponding front view will be parallel to HP, because this is the true length in HP. So obviously this front view has to be parallel to HP. So here, since it is the true length in HP, that is point P is above HP by 15 mm, and point Q2 should also be above HP by 20 mm. So that is what 15 mm. So you that PQ2 will be the line which will going to be the true length in space. Small capital PQ2, which is on the HP, will going to be the image on the horizontal plane. Now, when you project from the front view, both P, which is P dash here, and Q2, which is Q2 dash here, which will be parallel to HP. So to get this point, so what we are doing is, first you draw a vertical projector from here, so that this is the projector what we seen in the space. So that image is here, so you will go to project this till here. Then when you look from the top view, you will going to get this line till here. So this is Q2, which has been the above HP by 15 mm. So this is the line which will going to be above HP. So that means, since it is the true length in HP, so it will going to be made parallel to HP. So from Q2 you draw a vertical projector till to the XY line. From here you draw a vertical projector such that it will going to cut the locus of P in the front view, so that P dash Q2 dash will going to be parallel to HP. Once you find the parallel to HP, so this is the front view point of Q2. Then Q2 dash, the end projector of this Q2, the end point of Q2 will going to lie on this end projector in the front view. So with P dash as center, take the radius of P dash Q2 dash, then draw an arc such that it will going to cut the end projector at this point, so that you will going to get this q dash, and then once you get this q dash, so we will going to get the locus of q in the front view, which will be locus of q in the front view. So by doing so, what we are doing is, with P as center, taking the radius of PQ2, draw an arc such that the Q is such that the Q, it will be which will be draw an arc such that at this point Q2 will going to be on the end projector of this line, so that you will going to get that point PQ, that is Q will be here when it is projected. So it will going to cut at this point, which will going to become the Q dash, which will be on the image. So P dash Q dash is the front view line. So join P dash Q dash with a dot line. Once you get this Q dash, then you will go to get the dash dot line, which will going to be the locus of Q in the front view. Now we need to find out. So now we need to find out the true length in the vertical plane. So to find out the true length in the vertical plane, with P as center, take the radius of PQ and draw an arc such that both P and Q1 will going to be in front of VP by 30 mm. So how do we do that? So with when you are rotating like this, with P as center, take the radius of PQ and draw an arc such that PQ1 will going to be parallel to VP. So that is what we have taken from here, PQ. When he has rotated PQ, then when P and Q1 both will going to be in front of VP with respect to the XY line. So this distance will going to be 30 mm in front of VP. So PQ1 is the line which is parallel to VP. So this is the line which will going to be get in the true length of the line in the front view, it is here. So this is in space. When it is projected, you are going to get this P dash Q1 dash, which will going to be the line, which will be the true length. So to do that, so here we will draw a vertical projector from Q1, because PQ1 is parallel to VP. So is projected Q1 to this XY line, and then you are projecting this Q1 to the locus of Q in the front view. So we will go to get this Q1 dash. Then join P dash Q1 dash with a little bit thicker than the projector line. So this point will be Q1 dash, since it is parallel to VP. So we are getting the true length here. So we mark this point as capital Q1 and capital P. So the inclination made by the true length with respect to HP is theta. The apparent inclination made with respect to the front view with respect to HP is alpha. Similarly, phi and beta. Now we know, so since the end projectors distances we have got now, so we measure the distance between the end projectors and also the front view distance, which will going to be P dash Q dash. So this is how we will be able to analyze the problem in 3 dimensions. Now we will going to solve this in orthographic view. So first we are going to draw the XY line and mark XY and mark VP and HP, which is as shown. Then end P is 30 mm in front of VP and 15 mm above HP. So from the XY line, you measure the distance of 15 mm above XY line, because VP is above XY line. Then draw a horizontal line such that it is 15 mm above HP. And NP is 30 mm in front of VP. In front of VP is seen in HP. HP is below XY line. From this point, you measure 30 mm in front of VP and draw a horizontal line. Consider any point on this and draw a vertical projector, so that it will going to cut both the lines at P dash and P, which is as shown. Then show the dimensions of 15 and 30. Then the NQ is 15 mm in front of VP. So in front of VP is seen in HP. So HP is below XY line. From the XY line, you measure 15 mm and draw a horizontal dash dot line, which will going to be the locus of Q in the top view. And then he says above HP. So the line is above HP, but we don't know what is the distance. We need to find out that. Then the top view of a line capital PQ is 75 mm long, measures 50 mm. So he has given the top view as 50 mm. With P as center, by using the compass, measure a distance of 50 mm and cut an arc on this, so that you will going to get the top view point, small q, and then join P and Q with a dark line. Similarly, by using the compass, you measure a distance of 75 mm long. With P as center, cut an arc on this locus of Q, so that you will going to get this Q2. which will going to be 75 mm long. So you will go to mark this. Now once you get the top view, the front view of this point should lie on the same end projector. So you draw a vertical projector from Q above HP now to the vertical plane. Now we know that this is the true length in HP, so obviously that line has to be parallel to HP. So this is the one condition. And since we know this, PQ is the line which is parallel to, which is inclined to VP. So this is the top view. You make that line parallel to VP. With P as center, take the radius of PQ and draw an arc such that PQ1 will go to be parallel to VP. Then draw a vertical projector from Q1 to the front view. So you're going to get this front view here. But since it is parallel to VP, so you're getting the true length in VP. So you know that the top capital PQ is 75 mm long. With P dash as center, take the radius of 75 and cut an arc on this so that you are going to get this point Q1 dash. Then draw a horizontal dash dot line which will go to share the locus of Q in the front view. So since this PQ1 is parallel to VP, so you're getting the true length. You join between P dash and Q1 dash with little bit thicker than the projector line. So mark this as capital P and capital Q. So once you get the locus, now we will going to find the apparent length in the front view. So to do that, from Q2, since it is the true length in HP, so you have to have the line parallel to HP. So P dash is above HP by 15 mm. So Q2 should also be above HP by 15 mm. So draw a vertical projector from Q2 such that it will going to touch us the locus of Q in the front view, with such that P dash Q2 dash will be above HP by 15 mm. That is what we have done here. So again with P dash as center, take the radius of P dash Q2 dash to draw an arc such that it will go to cut the locus of Q in the front view at this point. So that you are going to get this Q dash, and this Q dash and this Q will go to lie on the same line. So this will going to be the distance between the end projectors, which you need to be found out. So since it is P dash Q dash, we need to find out the length of the front view by using the scale. You measure the length of P dash Q dash, which will going to be 73.48 when you're doing it in computer. When you're doing it in manual, it will be 73 mm. Similarly, you measure the length from the distance between the end projectors between P dash and Q dash and P and Q, which will be the distance G is equal to question mark. So you're going to get it 47.70 when you're doing it in computer. When you're doing it in manual, it will be 48. So by using the protractor, you measure an angle of true inclination with respect to HP, which is theta, which will be equal to 48.19 when you are doing it in computer. When you are doing it in manual, it will be 48. And then similarly, you measure the angle alpha, which is the apparent inclination with respect to the front view, which is HP. So measure the angle of P dash Q dash with respect to HP, and that is with respect to XY line. So that alpha will be 49.53 when you are doing it in manual. When you are doing it in computer, when you are doing it in manual, it will be 50 degrees. Similarly, by using the protractor, you measure an angle of true inclination with respect to VP, which is phi, which is 11.54 when you are doing it in computer. When you are doing it in manual, it will be 12 degrees. Similarly, you measure the angle of apparent inclination with respect to VP, which is beta. It will be 17.46 when you are doing it in computer. When you are doing it in manual, it will be 17 degrees. So this is how we will be able to draw the solution in the sketchbook. So this is the final solution, what is expected in the examination. Now we are going to analyze it in stepwise. Let us see now. So here, first we are going to draw the XY line and mark VP and HP, and first you measure the distance above HP, which is 15 mm, and distance in front of VP by 30 mm. You mark these two. Then consider any point and draw a vertical projector. You mark this point as P dash and small p. The distance in front of VP, which is seen in HP, so this will going to be the locus of Q in the top view. So you draw a dash dot line here. Then you measure the top view distance, which is 50 mm. With P as center, take the radius of 50 and cut an arc on this locus so that PQ will be parallel to VP. PQ will be the line which is the top view. And similarly, has given the true length distance, which is 75 mm. With P as center, take the radius of Q2 and cut an arc on this so that you will going to get this Q2. So once you get this, now we need to do the parallel. So here with P as center, take the radius of PQ and draw an arc such that you make it parallel to BP. So you're going to get PQ1. Once you get the parallel to PQ1, so you draw a vertical projector from Q1. Then since you have the true length, since it is parallel to VP, so you're going to get the true length in VP. So by using measure the length of 75 and cut an arc on this so that you will going to get this point, which will be P dash Q1 dash, which will go to the true length, and inclination made by this with respect to HP is theta. So this will going to be the locus of Q. Then, so this is what we have done here. You make it parallel to VP. So you are rotating like this and then you are projecting. So you are going to get this. This has been already explained. Now, in the top view, when you are taking this, you take PQ2. You draw a vertical projector from Q2 to the front view such that P dash Q2 dash is above HP by 15 mm, because PQ2 is the line which is true length in the HP. So you are make it parallel to HP. Then the top view point is here. So the end projector of the Q dash should lie on this line in the front view. With P dash as center, take the radius of P dash Q2 dash, draw an arc such that it will going to cut on this end projector so that you will going to get this point Q dash. Then join P dash Q dash with the dark line. So this is what we have done. With P as center, take the radius of PQ, rotate it such that you made it parallel to HP. So you are going to get the true length in HP here. So this is how we will be able to analyze the problem in the sketchbook.